Hello, in this video we are going to see the relevance of data warehouse, data lake and data marts. Why, what and how of these important data concepts. Let's get started. We'll go in depth on all these concepts which are being indicated here. But before going in depth, let me give you a cursory view of what exactly is a data warehouse. In any enterprise, we have multiple systems which are there. For example, in a bank, there could be departments like legal, risk, compliance, retail banking, corporate banking, private banking, investments, and so on. So there may be different data sources which may be there, multitude of data sources which may be there in any enterprise of any degree of complexity. So if in case we have to do an analysis on all this data, and all these data are related in some way and they should be stored somewhere in a way that the analysis can be performed on that data. So that's what is the purpose of warehouse, wherein we collect the data from a multitude of sources and we place it into a data warehouse. And from the data warehouse, either we can do the analysis job directly on the data warehouse, or we can create data marts. And data marts are what? Data marts are meant for specific departments, specific groups within the enterprise, and they would be querying the data inside the data mart. And what this helps is in having a faster execution of the data, plus they are only viewing what is relevant for them. So the users which need to see the data from purchasing, they would be going here and running their analysis jobs against the data mart on purchasing. All these things would be explained further with a degree of simplicity, but this is a overall understanding of data warehouse. Let's see the definition from Mr. W.H. Inman, who is considered as the father of data warehousing. So what he says are subject-oriented, integrated, non-volatile, time-variant collection of data in support of management decisions is a data warehouse. So what is subject-oriented? So any enterprise would be having data with respect to that enterprise, with respect to that subject, that is subject oriented. So data does have some subject, that is subject oriented. When we say integrated, means we are collecting data from multiple sources and having a integrated view. So non-volatile, what is non-volatile? Volatile is something which is changing. Non-volatile is once the data is entered to data warehouse for analysis, it does not change. So for example, if I enter a data of let's say pricing today, the pricing data of today would remain as is. If I have to introduce new data tomorrow, that would have a different dimension to it, and that would be tomorrow's data. Okay. Similarly, next month's data. So previous data is not disrupted. It is like non-volatile. So whatever data we enter is non-volatile. And time variant. Data warehouse stores data in a time stamped way. Like this data is of this specific time period. So that is time variant collection of data in support. So all this data collection, integration, all these things we are doing so that it can support in strategic decision making for the management. So that is in support of management decision. So this is a very comprehensive definition of data warehouse. In a transactional database, what is transactions? So transactions are a sequence of one or more SQL operations that are executed as a single unit of work. So single unit of work means either they pass, succeed, or they fail in entirety. It cannot be that some part of the transaction has succeeded and some part has failed. So for example, let's say I'm doing transfer of money from my account, one account to another account. So it should not be that in my first account, the money has been debited, but in the second account, it has not been credited. So that is not a transaction. Transaction means if it is failing at one end, then nothing will succeed, neither debit nor credit. If it succeeds, then everything like credit and debit, both would succeed. And we have to remember these asset properties to understand the transactions. So A is meant for atomic. So atomic is that every transaction is done as a unit. It either fails or succeeds in entirety. Consistency means that the database would be in a stable and a valid state once the transaction is completed. It would be consistent with the rules, the referential integrity rules, and the constraints which are there in the database. Isolation means that the database would be when we are executing multiple transactions, they are executed in isolation from each other. So one transaction is not going to affect any other transaction. And D stands for durability, which means that once the transaction is committed, it remains so. It cannot be that you restart the system and the transaction is not committed, which means you are still seeing the previous state of the database. Or if there is a crash or something, if the transaction has been successfully completed, then it will be durable. Now, once we have understood the transactions, we would appreciate what is OLTP, online transaction processing. So all the databases, relation databases which we see are OLTP databases. And these databases are designed to handle large number of short online transactions such as insert, update, delete that involve small amount of data. So all the systems which are used for your day-to-day operations, they are using database on real time or near real time basis. They are OLTP databases where the rules of transactions does apply, and where we do crude application of databases, which means create, retrieve, update, and delete. Data analysis. So if in case we are having data and we want to analyze the data, that is what is the data analysis. So data analysis is a process of inspecting, cleaning, transforming, and modeling data with the goal of discovering useful information, drawing conclusion, and supporting decision making. Data mining. So data mining is little involved in data analysis. Here what happens is we are again doing similar things like discovering patterns, correlations, or relationships with large set of data, but it involves usage of complex algorithms and AI and machine learning and statistical analysis. And these analysis analyze the data from various angles, searching for recurring patterns, correlations, anomalies. These might involve looking for buying habits among customers, identifying fraudulent transactions, or understanding what factors influence social media trends. So this is data mining, where you are analyzing the data, you are grilling the data, you are going inside the data, you are using complex algorithms and identifying these patterns from the data. OLAP. So analytical processing. So we understood OLTP earlier, transaction. OLAP is meant for query and analysis rather than transaction processing. So OLTP was for transaction processing. We were doing create, read, retrieve, update, delete, those kind of operations. In OLAP, we read, we query the data, and we try to get the analysis from the data. So what we do, these systems are optimized for complex queries, aggregations, and data mining, making them ideal for business intelligence, reporting, and decision support. So we are using these more for reading, and we don't update the data here. We read the data, we run complex queries, and there is a huge amount of data which is in the OLAP systems. So the query performance, complex query performance is of utmost importance. Materialized views. So what happens is, if in case we have complex queries and we are fetching the data from views, then the views would be getting the data from the tables. They would be running, let's say, joins, complex queries, retrieval of data from multiple tables, and then it becomes very slow. The query execution becomes very slow. So that's where materialized view, what they do is they fetch the data in advance and put the data in the data store in advance, thereby enhancing the performance of data fetch from the views. So let's read the formal definition. Materialized views are database objects that store results of query physically. Physically is very important. Physically on the disk. So they are creating their own data store. Unlike standard view, which dynamically retrieves data from underlying table each time it is accessed, a materialized view stores the query result and can be refreshed periodically to stay updated with the underlying data. So it can be refreshed so that it has the latest and greatest data. This approach can greatly enhance performance for complex, resource-intensive queries, as it avoids the need to recompute results repeatedly. Data mart. So we already saw data warehouse and we saw data mart also. So data mart was meant for specific subset of data from the data warehouse and for quick analysis. A data mart is a specialized subset of data from data warehouse designed to serve specific needs of particular group of users within an organization. So if we see here, scope of data for data warehouse is enterprise wide, and for the data mart, it is department wise. Number of subject areas here would be multiple, but data mart would be a specific subject matter which we want to analyze. That would be data mart. Data lake. So in data warehouse, what we had done was we had collected the data, we had transformed the data, and we had put it into data warehouse wherein it was meant for analysis. Now in data lake, we store the data in as is format. So within that organization or the enterprise, data may be coming from multiple sources. So if we keep the data in as is format, okay, in a data store, that is a data lake. We are not doing any processing. We are just storing the data in as is format. So a data lake is a centralized repository that ingests and stores large volumes of data in its original form without any transformation. The data can then be processed and used as a basic basis for variety of analytical needs. Due to its scalable architecture, a data lake can accommodate all types of data, including structured data, which is like database, Excel sheets, etc. They are structured. Semi-structured like XML, JSON files, web pages. Unstructured, which is like images, audio files, tweets. So it can store all these different kinds of data in the data lake in its original form. Now, when we are writing the data in the data lake, there is no schema of data because we are just storing as is. But in the, let's say we are putting the data in an operational store or in a transactional database, then there is a format of data which is already identified. For example, in an employee table, there would be employee ID, employee name, employee address, all those things would already be there. So there is a schema defined. So when you are ingesting the data, when you are putting the data here, the schema is available while writing the data. That is schema on write. But in the data lake, the data was stored in its native format, the raw format. So there is no schema which was defined. So when you are reading the data, at that time you have to have the schema there, that this means this data means this. So that is schema on read. Unlike traditional databases which enforce schema when data is written, schema on write, data lake uses schema on read approach. So the comparison, we already studied that data lake is meant for structured, semi-structured, unstructured. Data warehouses for structured database. Schema on read, schema on write. Format is raw, and data warehouse it's processed. We do a transformation on the data and then we store in the data warehouse. Scalability, easy to scale because what we are doing is just increasing the amount of memory which is there. But here it is difficult and expensive because we have whatever new data we ingest, we have to have transformation rules. We have to increase the space in our store. That additionally we have to have the transformation of the data also accounted for. Users, data scientists and data engineers, because what they can do, they can run some algorithms directly on the data and identify patterns. And here it is more of business analysts which are reading the transformed data and drawing patterns out of it. Use cases, machine learning, predictive analysis, real-time analytics. Here it is for reporting and business intelligence. So these are the key data warehouse solutions which we have. Redshift from AWS, Azure Synapse Analytics from Microsoft, Google BigQuery, Snowflake, Teradata. These are the prime solutions which are available. So example of data warehouse in Azure, it can be implemented in different ways, multiple ways, but one of the implementation would be like this. So you are ingesting data from multiple sources, this ingestion with the help of this pipeline, and then you are putting the data in a lake, data lake storage, and then you are transforming the data and placing it into the data warehouse. This is the data warehouse where you are placing Azure Synapse Analytics, and then you are using the analysis and reporting with the help of Power BI. Another implementation in AWS, this is for a retail store. So retail store may have an online presence and it can be a hard brick and mortar store also. So you are ingesting the data and then you are doing some transformations. The data has come to the S3 for the click stream. It's a real-time click stream. So we are using Kinesis streams and we are putting it into S3. Similarly, for retail store, we put in S3, we do some processing using EMR, Elastic Map, Reduce and Glue, and place it into S3. And then from there, all these data sources are going to the data warehouse solution from AWS, which is Amazon Redshift. And then you use QuickSight to analyze and visualize the data and draw patterns out of it and conclude from the various analysis drawboards which you have drawn there. Okay, thank you very much.